Hello friends, welcome to this video session of Robotics Engineering. This is an open elective one which will be offered by Automation and Robotics Department. My name is Sujit Kumar, Assistant Professor, Automation and Robotics Department. Today we are going to see the detailed syllabus and the importance of robotic engineering. So first, why robotics engineering? The robotic engineering field falls under the category of electrical, mechanical, electronics and computer engineering. Basically, it is the blend of these four branches, namely electronics and telecommunication, computer engineering, electrical engineering and mechanical engineering. This robotic engineering involves designing, building and engineering a robot. For example, for a new application, if you want to design a robot, that designing of robot can be done by robotic engineering. It is also practical design role in the research field. As a robotic engineer, you may develop robotic application across many industries including automotive, aerospace, manufacturing, defense and medicine application. Especially for computer engineering students, you may spend much of your time working at computer designing new product or workstation assembling prototype for testing purpose. Some robotic engineer can also work on site at manufacturing plant overseeing robots as they operate on assembly lines. You can specialize in the area of mobility application, sensing and perception application. This application is related with electronics engineering. Operator interface, this specialization can be of electronics and telecommunication or computer engineering. Manipulation and effectors, especially for mechanical engineering, and programming a robot, this application especially for computer science and engineering. So if you go through this particular content, you might be able to know this robotic engineering is not limited to particular one branch. It is a blend of these 4 to 5 branches. So we will see the unit-wise content of this robotic engineering. So unit number 1, robot basics. We will require 6 hours to complete this. In this robot basics, we are going to learn robot, the definition of robot according to different organization, the different definition of robot, the concept of robot, the need of robot, why robot is used nowadays, different laws of robots, history of robots, anatomy of robots, specification of a particular robot, robot configuration like Cartesian configuration, cylindrical configuration, polar configuration and articulate configuration. This configuration and its application we will see in unit number 1. Along with that, we are going to also learn robot wrist mechanism, precision and accuracy of robot. If a task is given to robot, so how precisely, how accurately it is doing with the help of robot wrist mechanism, that we are going to learn in unit number 1. Unit number 2 especially related with end effectors. This end effector means the part from where the robot is doing a work. For example, if we consider human hand, so that wrist is end effector of human. Similarly, the robot that is applying for particular application, its classification we are going to learn first, then types of actuation, mechanical actuation, then gripper design, robot drive systems, then position and velocity feedback devices, robot joints and links, types, motion interpolation. We are going to learn in unit number 2. Unit number 3 is related with robot kinematics. In that we are going to learn basic of direct and inverse kinematics, robot trajectories, transformation scaling, rotation, translation homogeneous transformation, control of robotic manipulation, point-to-point continuous path, robot programming, etc. This is related with unit number 3. Unit number 4 is related with robot sensors. So as you are aware about sensors, different sensors are used everywhere. For example, pressure sensor, temperature sensor, etc. Similarly, in case of robots, different sensors are used, that is touch sensor, tactile sensor, proximity sensor, range sensor. Some force sensors are also used to sense the force. Next, light sensors. So it will sense the different wavelength of light and it will act accordingly. Some pressure sensors are also used. Next important point in unit number 4 is introduction to machine vision and artificial intelligence. This part is particularly related with computer engineering. Unit number 5 is related with robotic program. So as you are aware of, these robotic engineering particularly related with 3 to 4 branches. Out of that, computer engineer plays very important role to do a programming. So introduction to robot programming, online programming, manual input which is given to the robot, lead through programming, teach pendant programming, offline programming languages and simulation. This is all about robot programming. Unit number 6 is related with control components and sensors. Here, mechanical control by stops and cam, solenoids which is related with electrical part, solenoids, relays, that is internal sensors, then potentiometer, then resolvers and encoders, external sensing, that is simple touch sensing, strain sensing, tactile sensing, acoustic sensing, magnetic sensing, capacitive sensing, laser sensing and machine vision. So this is the content of unit number 6. So if you learn this particular course, then at least the basics of robots you will learn. So some applications of robot. So these are some applications of robot. The first picture shows the robot is doing spot welding or welding type of work in automobile sector, line assembly. Second application is in industrial. Here the robot is lifting one workpiece. Third image shows that a robot is doing its application on that particular assembly line. Picture fourth shows a robot is doing a surgery. In surgery also we are doing robot. Some knee replacement surgery, some dental surgery, some heart surgery, brain surgery, robot plays vital role. Here also some the part or the work which cannot be done by human, that work can be done easily, especially in a COVID-19 situation. The robot were collecting the samples. One more picture which is shown here, that is in assembly line or manufacturing of bottle. The robot is doing its work. One application which is shown here, that robot is taught to just lift that box and to just place that box at proper place. In nearby hotels also, a robot is serving some food. One image which is shown, that is last image, the robot is taught to just pick and place and that object is sent to the worker. So this is the list of textbooks, that is Gonzalez, Robotics, McGraw-Hill's, then Robotics for Engineers by Y. Korean, Robotics by Craig, Introduction to Robots, Said Niku, Robotics Engineering and Integrated Approach by Richard Clafter, Robotics and Control by R.K. Mittal, Introduction to Robotics by S.K. Saha, Robotics by S.K. Ghoshal. This is the text. This is the list of reference books. That is Robotics Fundamental Concept and Analysis by Ghoshal, Robotics by Kutan, Applied Robotics by Edwin Weiss, Robotic Engineer and Integrated Approach by Clafter, Control in Robotics by B.K. Ghosh, Embedded System and Robotics by S. Ghoshal. So thank you for watching this video. Thank you very much.